In this section, we are learning about a subset. When set A is a subset of set B, we express them as A, and then the U-shape turn to the right side with the line underneath that, and then B. Now, if every element in set A is also an element in set B, so this is the notation for the subset. Now, if you draw the diagonal line across the symbol, then that means A is not a subset of B, and that means that not all or at least one element of A that is not an element of B. Now, every set is a subset of itself because it has all the elements of itself. Okay, example. We have set A 1, 3, 5, 7. Set B contains 1, 3, 5, 7, 9, 11. Set A is a subset of set B because all the number 1, 3, 5, 7 are inside the set B 1, 3, 5, 7. So all the elements of A are inside the element of B. Another example. Now, set A is the X such that X is a letter in the word proof, B-R-O-O-F. Now, this is the set of Y such that Y is a letter in the word roof, R-O-O-F. Now, this should be B. Now, set A is not a subset of set B because not all the elements of A are inside set B. We are missing the letter P. So P is not here. So that is the definition of the subset. The next one is the proper subset. Set A is a proper subset of set B when we can express as A and then the U-shape turn to the right B without the line underneath that. If set A is a subset of set B and set A and B, they are not equal. Okay, so A is a proper subset of B when all the elements of A belongs to B. So set A is a subset of B. However, there is one more requirement. Set A and set B, they cannot be equal. That's why we don't have the line of equal underneath that, as you saw earlier. In this example, using the symbol subset and proper subset or both to fill in the blank to form a true statement. The set A is all the X such that X is a person and X lives in San Francisco, and B is the X such that X is a person and X lives in California. Now we know that all the people who live in San Francisco, because San Francisco is inside California, so everything of A is inside B. So we know that A should be the subset of B. However, as set A and B, are they equal? If they are not equal, then we have them to be a proper subset. A is a proper subset of B. Now, California has a lot of different cities. Therefore, the San Francisco one is not equal to the whole state of California. Therefore, A and B, they are not equal, and A is the proper subset of B. So in this case, the subset and the proper subset are all true for A and B. The second one, set A has 2, 4, 6, 8, and then set B has 2, 8, 4, 6. Now we know that 2 and 2, 4 and 4, 6 and 6, 8 and 8, all the elements of A are inside the element of B. So A and B, they are the subset. A is the subset of B. However, because we have the same elements of A and same element of B, they are equal. In this case, A equal to B, and if A and B are equal, A cannot be a proper subset of B. The proper subset only happens when A is not equal to B. The next topic is the subset and the empty set. For any set B, the empty set is the subset of B. So the empty set is the subset of any set. And for any set B other than the empty set is also a proper subset of B. So this is the important rules about a subset. The empty set is a subset and also the proper subset. The last objective for this section is about the number of the subsets of any given set. So for example, I have the set. This has nothing inside the set, so the number of the elements is 0. Right, it's 0. And you don't have any subset, so it's just the empty set. So the number of the subset is just 1, the empty set. Now for the set of one element, you have the number of the element, which is 1. So we can list all the distinct subset, which is A, and also the empty set. Remember that the empty set is a subset of anything. Go back to here. Okay? And then the set of A and B, we have 2 elements. And then we can list the distinct subset A, B, or the empty set. Okay? Now, for the 3 of them, A, B, C, the number of the elements is 3. We can have A, B, C, we can have A, B, or A, C, or B, C, or A, or B, or C, or the empty set. So we have the total number of the subsets is 8. Okay, so you can see the pattern here. For 0, you have 1. For 1 element, you have 2. For 2 element, you have 4. For 3 element, you have 8. So you can see that the number of the subset is related to the number of the element inside a set by this formula, 2 to the n. And n is the number of the elements. So for example, this one is 1 element. So the number of subset is 2 to the first power equal 2. This case, we have 2 elements. The number of the subset 2 to the second power equal 4. And A 2 to the third power, because there are 3 elements, and that is 8. However, the number of the proper subset Remember the proper subset. You don't want them to be equal, right? You don't want them to be equal for the proper subset. So you have to subtract one element out of the total. So the number of the proper subsets with any n elements is 2 to the n minus 1. Whatever you get here, minus 1, and you get the proper subset. For example, find the numbers of the subsets and the number of the proper subset. We have 1, 2, 3, 4, 5. So n in this case is 5. 5 elements. So for the subset, we have 2 to the n power, which is 2 to the 5th, equal 32. So there are 32 subsets. And then we just take 32 minus 1 to get the proper subset. So take the subset, subtract 1 to get the proper subset. Now this one, x belongs to the natural number, and it's between 9 and 15. So we can see that 9 and 15, we have 9, 10, 11, 12, 13, 14, 15. So 1, 2, 3, 4, 5, 6, 7. We have 7 elements. So n equals 7 in this case. Then there are 2 to the n power, 2 to the n, which is 2 to the 7, or 128 subsets, and subtract 1, which is 127 proper subsets. So subtract 1 to get you the proper subset. And that is the end of 2.1.